Hello, I'm going to present an empirical investigation of mature information skill learning. This is a joint work with Ben and Ross. We are working on the problem of unsupervised skill discovery, in which the goal of the agent is to learn a set of diverse skills in an unsupervised training phase and to adapt these skills in a downstream adaptation phase. The common approach in most of today's algorithm is mutual information maximization. So we define our skill prior distribution. We have our observations, a skill condition policy that takes the observation and the skills as an input, and output distribution over actions. And the objective is to maximize the mutual information between the observation and the skill. Intuitively, this tells the agent to uh, acquire a set of skills that are highly informative of the observations. This objective is defined as the expectation under the joint distribution of the log of the ratio between the skill distribution conditioned on the observation and the unconditioned skill prior. In practice, we can't compute this expectation exactly because it is intractable to integrate through this joint uh, distribution. So instead, we optimize for a variational lower bound on the mutual information, where Q phi is called the discriminator, and it is trained via maximum likelihood. And we define our intrinsic reward as the difference between the log of the discriminator and the log of the skill prior. In practice, we have plenty of design choices if we want to implement an unsupervised skill discovery algorithm. For example, the deep RL optimizer that will maximize the intrinsic reward, the skill representations, discrete or continuous skills, the number or the size of the skills, and the mutual information lower bound. So in this work, we ask the question, how do these design choices affect the downstream performance? We show that regularizing the discriminator improved the downstream performance by a large margin. In this plot, the x-axis represents different environments from the OpenAI Gym benchmark. The y-axis represents the extrinsic return after the adaptation phase, normalized by the performance of an expert policy. We also clearly see that applying weight decay has the biggest impact on the downstream performance. We also show that the choice of the mutual information lower bound also has a significant effect on the downstream performance. So in this plot, the x-axis and the y-axis are the same as the previous one. Different colors represent different mutual information lower bounds. And we clearly see that optimizing for the NFONC and the NWJ lower bound has a better downstream performance than the BA lower bound, which is the most common in unsupervised skill discovery work. In conclusion, we show that different design choices of unsupervised skill discovery algorithms can have a great effect on the downstream performance, especially regularizing the discriminator and the choice of the mutual information door bound. We still have some open research questions. For example, can we have a theoretical justification of the effect of the mutual information door bound, and how can we understand the effect of regularization on downstream performance? Check the paper for more experiments and feel free to contact me if you have any further questions. Thank you.